Alright, let's solve this question on the board. The question is under the topic equations of motion. And the question says, a palm fruit dropped to the ground from the top of a tree 45 meters tall. How long does it take to reach the ground? This particular question falls under the topic equations of motion. Now, equation of motion is a topic that JAMB frequently asks questions on. This particular question has been asked several times by JAMB, and we're going to solve it today. Now, let's solve it first of all. Like I always tell my students, before you solve any question, you bring out the parameters, right? The set of data that you are given in that question. Looking at this question, it says a palm fruit that is on the tree. They give us the length of the tree. They say the tree is what? 45 meters tall, which means the length of the tree, we can call the length, in this case, S. We call it 45 meters tall. How long does it take? They're asking us how long. How long talks about the time taken for that fruit that is on the tree to fall down to the ground. How long, which is time. They're asking us to calculate for time. Now, there is a hack, or let's say it's a hack, or a hint that we use to solve questions on equation of motion. Now, look at the hint. The first is when a body starts from rest, U is equal to 0. What do we mean by a body starting from rest? For example, a car is parked, and before that car starts moving, the car was at rest. That state at which the car was parked is a situation where we can say it is at rest. So if a car or a body, in this case a fruit, is at rest, this particular fruit is at rest because it is there, it is up. So it is at rest where it is. When a car is parked, before it starts moving, that car is at rest. Okay, so if a car is at rest and it starts from rest, U is equal to 0. What is U? U stands for initial velocity. Alright, the initial velocity is equal to 0. But when a body comes to rest, V is equal to 0. Can we see? If a body comes to rest, or let's use a car, when a car is moving and it's already on motion, let's say the driver wants to park it. That process in which the driver wants to park that car, it means the car is coming to rest, and V, which is final velocity, is equal to 0. When a body starts from rest, initial velocity, which is U, is equal to 0. But if a body comes to rest, final velocity, which is V, is equal to 0. Now let's solve this question. If you look at this question now, we can say that the fruit started from rest because the fruit was in a state where it wasn't in motion. It was just hanging there. It wasn't in motion. So the fruit started from rest. So we can say U is equal to 0. Now, there are 3 equations of motion that JAMBite for 2027, in fact, students in general, both WAEC students, JAMB students, and NECO students also should know these 3 equations of motion. I'm going to write them down here. The first is V is equal to U plus AT. The second, S is equal to UT plus 1 all over 2 AT squared. And the third, which is V squared, is equal to U squared plus 2AS. Please, these are the 3 equations of motion. You don't need to cram them, but when you solve more questions on them, it becomes inside of you. Now let's solve now. For us to know the particular equation or the particular formula we are going to use, you look at what you are given. What are we given from this question? We are given distance, which is the distance or the length of the tree, which is 45 meters. We are asked to calculate for the time. We are given the initial velocity to be 0 because the car or did I say the car? The fruit started from rest. Now, look at these three equations of motion. Which of them are we going to use? In this case, for the first equation of motion, we don't have any business with final velocity because the fruit did not go to rest. It started from rest. Okay, so we don't have a business with the first equation of motion. Now, looking at the second, we have from the question we are given s, we are given u, we are asked to calculate for t, and when we see a here stands for acceleration, s here stands for distance, u stands for initial velocity, t stands for time, a stands for acceleration, right? While the other t2 stands for time. But in this case, this is a palm fruit that is dropping down from the top of a tree, which means the acceleration this time is acceleration due to gravity, and it's a constant value. Acceleration due to gravity, g, has a constant value of 10 meter per second square. This is a constant value. Even if you are not given in the question, you should know that acceleration due to gravity has a constant value of 10 meter per second square. Now, so the best formula to use is this, the second one, because we have everything and we're asked to calculate for t. So let's solve. S is equal to ut plus 1 over 2 at squared. What is s from the question? 45 is equal to, what is u? U is 0 times t, that's what we are asked to calculate for, plus 1 all over 2 times, now a in this case is acceleration due to gravity, which is 10, times t square, that's what we are asked to calculate for, so we don't know what t square is. So we see what we did. I just substituted everything. I replaced the values here. I replaced them. That is how to solve it. Then we have 45 is equal to 0 times t is 0. 0 plus 1 all over 2 times 10 times t square. 10 times t square is 10t square. Now, if you look at this, you can simplify it further by saying 2 divide itself 1, 2 divide 10, 5. Alright, so now we'll be having, come here, we'll be having 45 is equal to 0 plus 1 times 5t squared. 0 plus 1 times 5t squared, because I simplified this term. Now we don't have a fraction again because I divided 2 by itself and divided 2 by 10. That gave me 5. Then I'm having 45 is equal to 1 times 5t squared is 5t squared, and 0 plus 5t squared is still 5t squared. Look at what I did. This is 0 plus 1 times 5t squared is still 5t squared. Just so you say 2 times 1, 2, or 1 times 2, 2. Right? So we are still having 5t squared. Now what do? We divide both sides by 5 because we are looking for t. We are looking for t. So we have to divide both sides by the coefficient of t squared, which is 5. We don't want 5 to be there. So 5 cancel 5. Then you have t squared is equal to 45 divided by 5 will give you 9. Right? Now, but we are not looking for t squared. We are looking for t. And what do? The best thing to do here is to take the square root of both sides because we want to eliminate this square sign there. So when you take the square root of both sides, you have, okay, we could just take the square root from here because of the board. Take the square root from here. Then this square sign cancels this square root. So therefore, t is equal to, the square root of 9 is 3. 3 what? Please, the unit of time is seconds. So 3 seconds. Please follow the steps. Follow the steps. It is not difficult at all. It is not difficult. You just have to know which of the formulas you are going to use. And you have to know if the body is starting from rest or if it is coming to rest. In this case, it started from rest. That is why the initial velocity u is equal to 0. Then we had to bring out the parameters. From what we were given, we deduced the formula we are going to use, which is the second equation of motion. We use the second formula and we just solved it down. Solved it, and we've got our final answer to be 3 seconds. So that fruit will fall to the ground in 3 seconds. That fruit that is on top of the palm tree will fall to the ground by 3 seconds. Please, WAEC and JAMB candidates for 2027, please like, share, and drop your comments. Please follow me, I beg you. Follow my page. Thank you very much.